Normally, we do trig functions using a calculator. However, our poor classmate really needs to submit his assignment, so let's try and figure out how to do it manually. Let's take the sine function. We'll try to approximate it with a polynomial function p of x, because they are easier to calculate. So first, we're going to match their y-intercepts. The y-intercept of sine x is 0, so we set p of 0 equal to 0, which leaves us with the constant term being, well, 0. But this isn't enough, as a lot of functions have the same y-intercept. What we can do is match their tangent lines at the y-intercept. Therefore, the derivative of sine x at x equals 0 must be the same as that of p of x. Calculating the value for sine x leaves us with 1. Applying the power rule to the terms of p of x and substituting x equals 0 leaves us with a1 equals 1. So, our graphs look quite similar near the y-intercept. However, we also want them to curve at a similar rate. For this, we will match their second derivatives, which is the rate of change of the rate of change, or the curve. Using a similar process as before, we get 2 times a2 equals 0. Therefore, a2 also equals 0. We can use the same process with higher order derivatives indefinitely. We get this series for p of x, which starts to bear striking resemblance to sine x. This polynomial is known as a Taylor series, and they reach impressive accuracy. We can find the Taylor series of cosine using the same method, and since the other trig ratios can all be expressed in terms of sine and cosine, we don't need to do those. We did it! Taylor series can be used to calculate trig functions completely manually. Thanks for watching, and happy learning!